All right, let's talk about something every data science learner bumps into: evaluation metrics for classification models. So you've trained a model and you get an accuracy of 95%. Sounds awesome, right? But wait, what if your data set is super imbalanced? Like only 5% of your data belongs to the positive class. If your model just predicts negative every time, it still scores 95% accuracy without actually learning anything useful. That's why accuracy alone can be misleading. To really understand your model's performance, you need the full picture, a combination of different metrics. Let's start at the foundation, the confusion matrix. Picture it like this. You have a table that compares your model's predictions to what's actually true. Here's how it breaks down. True positives. The model correctly predicts the positive class. Think of a medical test actually catching someone who's sick. True negatives. The model correctly predicts the negative class, calling a healthy person healthy. False positives. The model predicts positive, but it's wrong. A healthy person gets told they're sick. Kind of like a fire alarm going off with no fire. False negatives. The model misses a positive. A sick person is told they're healthy. That's a serious miss, especially in healthcare. Understanding these four numbers helps you calculate all the other metrics. Now let's dive into two big ones: precision and recall. Precision asks, of all the times my model predicted positive, how many were actually right? If you're building a spam filter, high precision means very few legit emails get lost in the spam folder. Recall asks, of all the actual positives, how many did my model find? In fraud detection, high recall means you're catching almost every fraudulent transaction. But here's the kicker. There's a trade-off. If your model tries to catch every positive, it might also flag a lot of false alarms. If it's super careful, it might miss actual positives. So what if you want a single score that balances both? That's where the F1 score comes in. The F1 score is the harmonic mean of precision and recall. It's like saying, how good is my model, considering both the quality and quantity of its positive predictions? Especially with imbalanced data, F1 is your go-to metric for overall performance. But metrics don't stop there. Say you want to see how your model performs across different thresholds. Enter the ROC curve. The ROC curve plots the true positive rate against the false positive rate for every possible threshold. And the AUC, area under the curve, gives you a single number between 0.5 and 1.0. Closer to 1? That means your model does a great job distinguishing between classes. So, the next time you're evaluating a classification model, don't just look at accuracy. Dig into the confusion matrix, check your precision, recall F1 score, and maybe even plot that ROC curve. Because when it comes to data science, a little nuance goes a long way. Thanks for watching. See you next time.